Actually, there are some similarities between Romanian market and our Turkish market. First of all, what I felt here today and yesterday, the regulation is immature. There are some gray areas. This is my own opinion. Sorry if I do mistake. And also, investors are a little confused. It seems like that because they are not aware how they could gain some money through an energy storage system. Do really they need the installation of these kind of systems? How do they expand their energy plans? I think there are a lot of question marks. So this is the immaturity, I guess. The financing is the second problem. Maybe in Europe, you got a lot of sources compared to our market. However, the investor could really find the right source and do an efficient investment. Still the question mark. I think we should begin with smaller capacities, like POCs. Actually, this year, 2024, is a POC year. So we consider with POC, I mean proof of concept. Maybe, and I also speak based on energy storage system because I'm representing the product. So we should couple our storage systems with existing plans, and also we should present them to the potential investors who want to penetrate energy sector. And two topics should be cleared. So first, regulation and financial methodology.
I had in mind, from what you said, that 2024 is a year of proof of concept. This is also a shift of paradigm for us because we're expecting live solutions that are efficient, that are ready to go, that are also competitive and that are financed. But I think this first wave of storage will also be the proof of concept, and it's a great perspective on us. What would be the solutions that you would have in mind right now in order to deploy more storage in an efficient way?
Actually, there are also some presentation here. So what can we do? Yeah, actually, we have 3 application areas, 3 or 4. Let's say one, we can install our storage systems as a backup to DC chargers. This is electromobility. Second, CNI applications, so commercialized and industrialized. So for the factories or entities, they need a power backup like huge UPS systems or just to replace their generators, gensets, or residential use, and also grid scale. So we got 4 directions, and before doing some grid scale investments, maybe we could stay at CNI section and also by charging, so we could learn how to work with local energy companies, distributors, operators, and small investors. That could be some samples for POC. Yeah.
And speaking of in terms of regulation, as how you see it in Romania, what do you have in mind in terms of possible changes that might drive this market even at an accelerated pace?
I heard something about localization rates, 75%, if I am not mistaken. So it's a very, very competitive rating in case of the product because localization takes time and money. So in Far East, so most of the entities are doing that for 20, 30 years. So the expectation is very much high if we should compensate this time period in only 1 or 2 years. So localization not only means just redirect the supply chain. So it's actually include many things. We should have skilled people and new factories. new trade agreements, there are a lot of things. So 75 is, I think it's a very risky and a competitive rating. That could change. We may start slowly. So first assembly, then production, then R&D, then being competitive in such a sector. So that could be the most logical way, I guess.
And this reminds me of what I've noticed at Mihai's presentation, from less material to more brain. We're now just in the phase of material, so building somehow the supply chain localization, then the factories, then having the skilled people, and then becoming competitive. So this is a very nice link.
Yeah, I can also start my presentation.
Sure.
I will try to summarize it to take not the whole time of the audience. So, YEO technology is actually a group of companies right now. So it's representing in this ecosystem many other startups and scale-ups today. YEO so far had realized more than 400 projects globally, over 30 countries, and today we are very skilled by EPC efforts. And we also added finance feature to our efforts and also coupled it today with energy storage systems. We also invest for best applications. Okay, pictures are gone. Okay, okay, no problem. So we can continue. So we got more than 10 locations in countries. We are doing projects. We realize projects. This is the Turkey countries region, Middle East, Africa, and even in USA. Today we do some projects. And most of the global actors are our suppliers. So we are working on power electronics and all the related stuff with major manufacturers. This actually representing our ecosystem. In different locations, we have project companies as partners in UK, in Azerbaijan, and also in Europe. We are partnering with those of the companies. We also have a branch, MicroHES. So we develop micro hydro turbines for low flow rivers. So we also produce electricity from them. Marine energy is for floating solar panels. And so we also develop our own structures. Even for hydrogen, we have a small R&D group. They just started their projects. Today, I'm morely representing the ReapBattery. It's our branding for energy storage systems, a full subsidiary of YEO Technology Group. NICAD is responsible for cathode material. We also working on our own receipt because we also aim to invest in cell manufacturing in Turkey. So we will actually complete the supply chain. So far we can. So this is actually what I meant before. So it takes time. So we are investing for a factory right now, but it's a module factory. So first we will take the cells and making group of cells. We marry them with our battery management system. So then you got the whole containerized solution plus the energy management system. It is actually something. So after that, maybe you can also invest further for the cell manufacturing. Brand IT is, this is according Industry 4.0. We digitalize our processes and also they support us by the new factory. The project group works together. Ion membrane, yeah, that's an interesting R&D group. So they develop actually the membranes for electrolyzers and also membranes for the one in the cell, the lithium-ion cell. Ratio is the company who develops the local energy management system. So InnoWatt is other colleague of ours in local market. Ratio is the, yeah, let's say the competitor. We also invest for the Ratio. And Solitech, this is our solution company for microgrid systems lower than 1 megawatt hour. Yeah, as always, also mentioned before in other presentations, we got the net zero targets, and so we are investing for it. So about these application areas, I already mentioned anything. Yeah, maybe here we can highlight our capabilities. Okay, cells are coming today as final products. So we took them and we design our own electrical structure with our software, the embedded software, the battery management system, and it comes a local EMS, another software. It's an interface between the grid and the battery itself. So PCS is a different kind of enabled power conversion system. Here you have to choose the right inverter to have an efficient system at the end of the day. We also, actually we will have also some partnerships in with some major suppliers. To do so, we need a really good working PCS to implement energy storage systems to different grids on the globe. And yeah, there are a lot of areas we say to applicate microgrid could be one of them, where the grid is weak, like in South Africa region. The factories representing the CNI application. It could be construction sites, mining sites where the electricity actually don't exist. Could be also the telecommunication sector. Earlier mentioned these 3G to 5G. They will also need backup systems in between. Data centers, so no one has mentioned before. Actually, for data centers, the investors have very strategical plans. You know, digital trade is today very popular. I mean, online sales, and therefore they have to install very secure systems. Mostly, they are in city, in a building. However, they should work 100%. So they should be very precise, and therefore backup power is very, very important for data centers. I think that will be one of the popular use cases in the near future, and so goes on. Yeah, these behind the meter and front the meter applications, everyone told one portion of it. So we can applicate our storage systems to factories, entities, charger operators, and also existing wind farms, solar plants, etc. Could be self-consumption, and even we could work with energy distributor companies. About the cell, actually, it's a new terminology today. So we hear a lot of these terms. Maybe a small explanation for these abbreviations. So DOD, depth of discharge, we have to limit the lithium-ion cell up and down. So it was difficult and almost impossible by lead-acid technology, but lithium-ion technology is doing that. So it is good for the health of the cell, which we call state of health. So the battery management system generally is measuring and monitoring state of the capacity and state of the health of the cell. You are as strong as your cell. The cell characteristic is also shaping the final product, the BESS, the whole energy storage system. Of course, with an efficient working BMS. Life cycle is always questionable. It is up to your frequency, how do you charge and discharge your storage system daily, and what are the ambient temperature or other conditions which may affect the condition of the whole system. With thermal management system and energy management system, we keep everything secure, and monitor them real time. It's a really high-skilled engineering job. This embedded software we actually localize in our company, so it is also good for the investor, for the potential customer, because if the regulation change, they will also need some changes in the system, and that because we actually got the whole structure. The whole design and software, we can easily modify it, alter it, according to the new power needs of the customer. And as mentioned, we own our own BMS, which actually also consists of hardware and software. This is our design and is suitable for 1500 volt level. Actually, electric vehicle business just started with 400 volt nominal voltage level, now is aiming to 800 volt level because we need power and more mileage. So if the demand goes high, you also have to be prepared by also hardware level for higher voltages and higher amps. But basically we have designed everything for 1500 level. It is also local. And so the whole structure is consisting of cell groups, power conversion systems, so HVAC, so the climatization, that could actually also alter regarding your structure. It could be air-cooled or liquid-cooled. We prefer to use liquid-cooled systems. Fire systems and also auxiliary systems, why we need for the other components. So everything we control with our local EMS, and EMS is communicating over CAN with BMS. And degradation is another question. The investors always ask themselves, okay, I will buy those kind of energy storage systems, but how long they can last? It's actually up to conditions and up to system configuration. They actually choose. So it could be 15 years, also 10 years. And what are you aiming? What is the regulation? For example, we see that 70% of the beginning of life is suitable for our markets. So we prepared ourselves for 1C application. 1C means one-time charge and discharge. It's like you got 10 megawatt hour energy storage system, and you can put the whole energy to the grid in just 1 hour. This is 1C. Okay, you could also choose 0.5C or 0.253C level. It actually affects the capex rating. So how many BESS should you mount on your site? And the second thing, the tricky thing, is degradation. So if you choose almost 2 times charging and discharging a day, with 1C application, you may reach 70% beginning of life level in 15 years. So this is actually the feasibility of most of the energy storage projects. These parameters are also showing that you have to start more than the limit the regulation actually defines, because if the degradation is high, you actually store more power. It is not enough only doing 10 megawatt hour, maybe 13, maybe 14. It is a calculation table, so you can have different approaches for that. Yeah, this is our basic strategy, cell to pack. Everyone is doing almost the same structure. Actually, we design our cabinets for something like 300 kilowatt hour level, and we multiply them. So we design the whole system, even for 10, 20, 80 megawatts, with these basic units. So it is very flexible. We can actually easily fit these cabinets everywhere. Even the land is not in a good shape. So we can be very flexible by designing the layouts, including the AC side. I mean the PCS, the inverters, etc.